Hello everybody, and welcome to the webinar Utilizing Color Sorting to Optimize Quartz Operations. It's a pleasure for us to have you on our platform. Good morning to our attendees in North America and Latin America. Good afternoon to our attendees in Central, Eastern Europe, and South Africa. And last but certainly not least, good evening to our attendees in India and Asia. This is Catalina Varga speaking. I work from TOMRA Mining in the sales department, and today I will be moderating the webinar. Let me introduce the team of quartz sorting experts who will be available to answer your questions at the end of the presentation. They are Markus Diller and Jens Bergman, based in Germany, and Harold Klein, based in North America. They have a vast expertise in color and laser sorting in industrial mineral markets worldwide. And today, my colleague Jordan Rutledge, sales manager in North America, will be presenting. Before we continue, let me say that this session is being recorded, and during the presentation, we will be asking some interactive questions. So your participation and your opinions are great value of us. So please join it. Also, you will find this question box available on your screen. Please write your questions down and our experts will answer them at the end. So with around 38 attendees listening, I will hand over the presentation to you, Jordan.
Thank you, Carolina, for the introduction. Good morning, good afternoon, good evening to everyone joining us from all around the world. We're very excited to have you all here today, and we hope that this webinar will prove useful. So I'm going to jump right in. TOMRA is a technology company with two main divisions, sorting and collections. Mining is within the sorting division alongside food and recycling. And we're very lucky here at TOMRA that we have such a presence within different sorting industries that all of our groups can benefit from sharing technology and knowledge. TOMRA has almost 25 years of experience in color sorting. With decades of operating in the field, this has allowed us to gain a high level of expertise and knowledge. We have an installed base around the world from North America, Europe, Asia, the Middle East to Africa. You'll find TOMRA Quartz customers. Finally, we're constantly developing new technology with the primary aim to provide solutions and value to our customers. Our main goal is to help our customers utilize their resources to the fullest potential, so achieving higher grades and recoveries while providing economical solutions that are also sustainable. In short, we believe that sorting is not only an economical solution to provide value, but also an environmentally sound technology as well. So, for those of you who are unfamiliar with sorting or maybe need a quick refresher, what is sensor-based sorting? First, it's a coarse particle separation. So you'll see particles in the magnitude of millimeters, not microns like flotation, and it's applied to the dry separation of bulk materials. Particles are first individually detected by a sensor technique. So this could be color, like we're discussing today, or other technologies like laser, near infrared, or X-ray transmission. Once these particles are detected by the sensor, they're generally ejected by compressed air. Finally, the feasibility of sorting largely depends on liberation characteristics. I had a wise professor in college that made all of the metallurgical engineers repeat over and over again, liberate before we separate. This liberate before we separate was the first question on every exam for the course, and it's wise knowledge that holds true to sorting as well. So we need particles to be well liberated to provide for an efficient separation. Looking at the main benefits of automated sorting, one of the largest is having the ability to rely on a technology to produce consistent quality. Lowering operational costs and reduced labor requirements particularly when comparing hand picking to color sorting, achieving higher throughputs in production, and finally having better recoveries and yield, directly improving the economics of your project. So I really like this diagram, and I think it's very helpful in understanding where sorting can add value along the process or pipeline. So from the mine to the mill, sorting can be used as a viable solution in the flow sheet. So just to highlight a couple of points here. Reliable and efficient sorting is having the ability to rest assured that your products can be made day in and day out, and is definitely a huge benefit. Having the ability to produce a variety of different products that meet targeted specifications for different customers is taking full advantage of all of your ore. And finally, there's tremendous value in improving your quality. So having the ability to generate a high purity, high quality quartz will increase the market value of your products. And Carolina will lead us in our first poll question.
Yeah, now is your chance to participate, and I would like you to answer the following poll questions. We have 15 seconds, and you just can select one option. So, what is the biggest challenge you are facing as quartz producer? Maintaining a constantly high quality product, the need to substitute hand picking, desire to decrease mining and processing costs, or the need to reduce water and energy consumption. Please just click on one of these options. And we will gonna get the results. Okay, so the biggest challenge that our audience is facing is maintaining a constantly high quality product, Jordan. Desire to decrease mining and processing costs, following by maintaining a constantly high quality product. So Jordan, now you will discuss some of the challenge we are currently observing in this industry, right?
Yes, thank you, Carolina. So regarding market challenges that we see, the largest one that we see is the popular trend of pure white designs being increased in demand. So the bright white quartz that's used to supply countertop and engineered stone materials industry. Like many of you answered, the challenge to maintain the quality needed to meet specifications, particularly with changing reserves and ore bodies. And finally, the decrease in good quality resources of this white material as demand continues. With regards to production challenges that we see, the largest one is often the reliance on hand picking in the process. So we know that this is a large percentage of quartz producers use at least some hand picking in their operations. And we know that this is challenging and time consuming. Most significantly, it's one that delivers limited quality control. So due to adding the human element, the decisions and performance varies from operator to operator, which adds variability into your process. In addition, there are serious safety considerations, including the exposure to silica dust and potential injury from conveyor belts. So just as a quick example, this is some of the stats that we've come across. So for a larger material from 40 to 150 millimeters, it would take 3 shifts of 55 people to sort 150 tons per hour. And for a smaller material from 2 to 10 millimeters, it would take 4 to 20 people to sort 1 to 5 tons per day. So hand sorting definitely requires a lot of workforce. So how does a color sorter actually work? You'll notice that most color sorters are going to be based on a chute system rather than a belt-based system. And one of the main reasons for this is that with a chute system, you can have cameras looking at both sides of the material, whereas on a belt-based system, only one side is visible. And I'm going to play this animation and kind of walk us through the process. So in this example, you can see a color camera and a near infrared camera. There's a small gap or opening in the chute where the cameras image the rocks as they pass by in freefall. After they're imaged, they're then classified as product or waste and ejected into the correct pile with a bank of hundreds of air ejectors. Looking at equipment, our sorting machines are designed with the particle size to be treated in mind. So we follow the nomenclature of crushing. Primary, secondary, and tertiary crushing roughly correspond to the particle sizes that you'll see in our primary, secondary, and tertiary sorters. So our primary sorter handles material from 50 to 250 millimeters with an expected throughput from 90 to 300 tons per hour. We have color, color dual, and color near infrared on the primary platform. Color being one-sided sorting, color dual looking at both sides of the rocks, and color near infrared being a combination like we saw in the animation on the last slide. Our secondary sorter handles material from 20 to 120 millimeters with an expected throughput from 40 to 100 tons per hour. We have the same options as our primary machine with the addition of laser and double-sided laser technologies as well. Finally, our tertiary sorter handles the smallest fraction from 2 millimeters to 32 millimeters with estimated throughputs of 5 to 25 tons per hour. The tertiary machine works on single-sided color and laser sensors. So if we take a look at how the sorter sees and classifies particles, on the far left is just a common photo taken by an iPhone. The middle image is the raw image of the particles as they pass through the sorter. And the right is the processed color image, which classifies each particle as product or waste. So you can see here that the white particles are classified as product and the red particles are classified as waste. Also, since we probably won't have perfect liberation, most particles will have both product and waste, and it's part of the program where we can decide how to classify these middling particles. One of the most important factors for having an efficient sort is proper material handling before the rocks even reach the machine. So in the crushing stage, having good liberation is definitely needed, while also looking to achieve a coarse size fraction, which helps improve your throughputs. In the screening stage, we want to target a narrow particle size distribution, which I'll discuss further in the next slide. And we also want to eliminate any fines or oversized material making their way into the sorter. Finally, it's critical that the material is washed prior to sorting. And this is because color sorting is a surface detection technique, meaning that we're making decisions based only off of what we can see on the surface of each rock. So here's a great example of why it's so important to wash the material. In the top dry image, we would classify the right 4 rocks as product. But when they're washed, we see that a couple of them would probably have been wrongly accepted. Regarding the particle size distribution, we generally recommend a 3-to-1 top size to bottom size ratio. And this just creates the best environment for an overall efficient sort and generates the best performance. So we've got a demo video to show you of one of our customers implementing color sorting in their quartz operation. So you can see the material being fed into the vibratory feeder, which evenly distributes the particles along the chute. Once they've been sorted, they have their product, which you can see there, and their waste. And I'd like to hand it off to Carolina for another poll question.
Thank you, Jordan. So again, I would like you to give your opinion on the next poll question. You have 15 seconds and you can select one option. Which particle size are you currently targeting for your products? Smaller than 10 millimeters, between 10 and 30 millimeters, 30 to 60 millimeters or larger than 60 millimeters. And the results, okay, 43% of our audience have between 0 to 10 millimeters, and 36% have between 10 and 30 millimeters, Jordan. Now you will gonna show us a flow sheet example of sorting different sizes.
Perfect. Thank you, Carolina. So we wanted to compare the flow sheets of traditional quartz operations versus using sorting. So on the left, you can see material being crushed and screened into 3 different size fractions, with under 10 millimeters likely going into fines or waste, 10 to 25 millimeters being sorted by hand with 4 to 20 people, and 25 millimeters and above being sorted by 40 people. So in the end, 2 products are made, 2 different size fractions of quality A material, and then your waste material. The right flow sheet shows an example of implementing sorting, where 2 size fractions are sorted at higher throughputs and reduced labor requirements. With the reduction of hand picking, significant safety improvements are also realized with the elimination of exposure to silica dust and potential injury from conveyor belts. In addition, it's feasible to further process that quality A material by crushing to smaller grain sizes and further liberating the material and implementing a second stage of sorting to generate a purer product. So in this case, it looked like quite a few of you said that your target range was under 10 millimeters. So this is a really good example kind of that size range area that we're working in. So in this case, 2 particle sizes or 2 particle ranges of quality A plus product are created, and also a lower quality B product. When we look at our customers and results, we've achieved higher than 95% recoveries and removed over 97% impurities. Sorting outcomes can largely be catered and optimized for the desired result. And often scavengers and cleaners are used for increased recovery and grade and are a good solution. So cleaning steps or reprocessing of the product from the first stage of sorting can improve the overall purity or grade of your product. While scavengers or the reprocessing of the waste from the first stage of sorting can provide an improved recovery. Just like other unit operations in mining, sequential steps can provide further optimized results. Having decades of experience in the quartz industry using color sorting, we have a large number of machines across the world. So this map shows where our quartz customers are utilizing color sorting, and you can see they're spread all across the globe. So let's take a closer look at one of these customers. In Turkey, TOMRA Mining currently uses a combination of laser and color sorting technology to create 4 different quartz products. With laser technology, they're able to produce quartz for the ferrosilicon or the metallurgical sector and a colored gravel for the aggregates industry. And if you're interested in learning more about laser technology and quartz sorting, we'll be having more info on the next webinar. With TOMRA color sorters, they're able to produce a white and light gray quartz with low iron content that's suitable for the engineered stone and countertops industry, as well as quartz for glass. So Microman has implemented TOMRA sorters at multiple mine sites and projects. They process a really wide range of particle sizes, so from really small material, that 1 to 4 millimeters, all the way up to larger rocks at 120 millimeters. Microman has seen improved quality by implementing sorting and by generating different grades of products and targeting them to specific industries. This has allowed for the maximum use of their ore. They have seen improved grades and recoveries, and finally have improved the health and safety by replacing hand sorting with automated sorting. And with that, I would like to hand it off to Carolina once again.
Thank you, Jordan. And as you already said, we want to invite you to our next webinar. This time, we will focus on laser sorting. This is the only technology available in the market and plays an indispensable role in quartz sorting in silicon metal and metallurgical productions. So if you haven't registered yet, please do it at the webpage tomramining.com. And I would like to take this opportunity as well to mention that you do have the possibility to send us your material to our test center in Germany. We will then perform a first inspection where we test our technology with a small sample of your material. And depending on the results of this first inspection, we will propose a performance test with a higher quantity of your material. Right now, we are doing virtual demonstrations to our customers, conducted by an application engineer and supported by a sales representative. So you are welcome to test your material. And now we have time for another poll question. Remember, you have 15 seconds, and in this case, you can click on two options. What are the two main factors you expect from a technology supplier? A company that offers a variety of technologies to optimize your process, a dedicated service network available 24/7, or expertise in the field in a large installed base, or a company that knows how to get the best quality results for your products. We have a couple of seconds more. And the main two factors that our audience expect are with 62% to know how to get the best quality results of your products, and with 48% a variety of technology to optimize your process. So probably you are still thinking why TOMRA is a proven partner. So let me summarize what we have learned is important to our customers. The first one, a field experience and installed base in each continent. The higher capacity and throughput that our sorters can achieve. An extensive service network. And the modifications that we can do to our sorters for tropical and Arctic conditions. And I want to focus on this one. TOMRA Mining has a variety of technologies to fulfill customer expectations. So now it's time to ask to our experts. Now you will have 15 minutes to ask your questions. If you haven't done it already, you can do it. I will hand over to Jens, Marcus, and Harold to answer those questions we have received during the presentation. Jens?
Yes, I'm here. Hello, everybody. Thank you for attending this webinar. I'm pretty happy to be here, and thank you, Jordan, and thank you, Carolina, for this nice presentation. We have received a few questions from the audience so far, and the first one wasn't really a question. It's just, hello, everybody, and thanks for the invitation. Suresh, thank you very much for this. We are happy to have you here. And I'm looking forward to see you in person next time. Question is coming in, where could I send the material for testing if I am located in Brazil, for instance? TOMRA runs actually 2 test centers around the world. One is based in Sydney, Australia. One is based in Hamburg in Germany. And we are constantly working on expanding these possibilities, but at the moment, it's the choice either to go to Australia or either send it to Europe to get the test work done. The next one, can you provide rough operation cost estimates for a single sorting unit? I imagine this can be scaled up based on capacity requirements. Do you also estimate the cost to rehandle material before/after the sorter? The operation cost of any kind of sorting machine directly depend on the capacity. And The capacity directly depends on the particle size we're dealing with, and the particle size again is determining the size of the sorting machine. Typical cost for, let's say, low capacity operations, which are, let's say, 5 to 10 tons an hour per sorter, range between €1 to €1.50, depending on the individual application. Just the operation cost. This is not with any depreciation, etc. If you go higher in the capacity, it very quickly gets much, much less. So if you go for something like 20 tons an hour, you're already around 50, 60 euro cents on a ton of feed. If you go up to 40 tons an hour, you're already at around 30 cents. And if you are up to 100 tons an hour feed rate on one unit, your cost per ton is about 15 to 20 cents. So this is directly related to the size. Oh, it's quite amazing. Lots of questions coming in here. You mentioned capacity, that's what I said, but TOMRA unfortunately does not estimate the cost to handle or rehandle the material before or after the sorter. That's very, very individual depending on the plant setup. It can be fully automized, it can be a batch operation. So we're not the experts in this field. Sorry to say this here. Then we have the next one. How much does a machine cost? Yeah, certainly that's much depending on the size of the machine. Generally, machine for a smaller material ranges from, let's say, roughly 230,000 euro. And the biggest one for the real big chunks like 250, 300 millimeter sizes, they can range up to 450,000 euro. So, but then they also have the highest capacity. Now, do you consider a different unit capacity when removing a small amount of waste, in brackets cleaning, versus removing a small amount of valuable scavenging? As a rougher step and a cleaner step, certainly the cleaner step we could feed much more because only a very small percentage of contamination has to be removed in the second step. But also here, the more you feed, the more, let's say, the lower the recovery, because you might hit some of the good particles by mistake and lose them. But certainly if you return them back to the feed, it's not really a loss. If you go for scavenging, certainly you could also turn the whole logic around and do not shoot actually on the colored contaminations, but then you shoot on all the clean, clear, white particles, and then it's about the same. The capacity of scavenging and cleaning, that's about the same. The rougher is typically a little bit lower in capacity because you have much higher levels of colored contaminants. How dry must the feed be for color sorting? That depends on the size. Typically, if material is bigger than 7 or 8 millimeters, the material can be surface moist. So we do not recommend to have water fall with some rocks in it in the machine, but if the material is screened and washed beforehand and you have a dewatering section on the screen and there's no dripping wet rocks coming anymore, then certainly the machines can stand this. Since this is a chute system and the particles, the slower they get, the more difficult is it to make them slide smoothly. And a smooth slide and a calculable sliding speed is necessary to hit the particles accurately. So typically from sizes below 7 to 8 millimeters, we recommend that the material is dry or better even dried to have a much better efficiency and much better sorting behavior here. Certainly it's a challenge because sometimes you don't have dried material, but you can also go for a good combination. But all this can be tested. This is what we have our test centers for, and sometimes it depends on the material. Then we do test work on moist material, maybe down to 4 millimeter, but it depends on the material, depends on the behavior, it depends on the crusher type. You know, if you have flaky pieces, they tend to stick. If you have round pieces, they tend to roll more and not stick. So it's all a very individual thing. We want to know more about your installations in India and for which application industry they are for. The installations in India are all focusing on engineered stones. So they produce white material for really kitchen tabletops, etc. And typically it's a multi-step operation, having a coarse step for the first roughing step, and having after a second crushing step, even after drying, having fine sorters, a fine sorter or fine sorters in place, which take care to remove the contaminants. What's the next one here? Kindly explain the difference between the color sorter and laser sorter. Which one is better? Yeah. I cannot say one of them is better. The thing about color sorter and laser sorter is the color sorter can only see colored contaminants. And a laser sorter can actually look into the crystal structure of the rocks. Let's see, a piece of quartz is one crystal, and it may glow in the dark, or glow more because of one crystal, because of this scattering effect. While a piece of, let's say, quartzite, which is the same chemical composition, but it consists of many little crystals together, just does not reflect any of the laser light. It is with the scattering effect, it just stays dark. So with this laser technology, we can even differentiate crystalline particles from non-crystalline particles, like a white piece of limestone or calcite, not calcite, limestone, or marble versus a white piece of quartz. You can separate them with a laser, but not with a color sorter. So here is another challenge or another advantage to combine these two technologies to get a better result, to have to solve different markets. But I think Jordan and Carolina will take care of this laser technology next week in the laser sorter session.
Yeah.
What's the next one here? Yes, do you have installations producing quartz for smelting, chrome smelter especially? We have installations producing quartz for smelting, not actually for chrome smelters, but also for silicon smelters or other applications where the quartz is used as the base mineral, really to produce metallic silicon or other silicones. And there are color sorters and laser sorters in place, which can provide the suitable quality here. What NIR info are you using when you're sorting quartz? Typically, the NIR signal of, let's say, of quartz differs from NIRs, or let's say from silicates differs from the NIR signal of carbonates. And they have totally different reflection behavior on this NIR spectra. So here we have a kind of a competition between the laser sorter and the NIR sorter, separating same colored material, where we always, during the test phase, we decide together with our clients which technology is the better one to be used on any individual application. Typically, so far, we have only sold color and laser sorters for this application. The NIR in this specific case has not proven to be that effective as a laser is. What is N? Hello, everybody, and thank you for the presentation. Can you please inform us about the space requirement for the installation of one sorter? Further, which is the height of the building needed? Konstantinos, thank you very much. First of all, the space requirements for the sorter itself is not very much. You have a sorter which is something like, let's say, 4 meters long, 2 meters high, and 2 meters wide. You have to put it on a pedestal on some kind of steel frame where you have the conveyor belts underneath. So you add another 2 meters underneath. So you have a feed height of 4 meters and the discharge, and then you need certainly the conveyor belt to feed that feeder with a typical angle of 16, 17 degrees. You know, you can calculate how long this might be, something like, I think, 10, 15 meters to feed it from the feed hopper. The discharge belts going out to the two belts going to the different piles, little building around it. I think altogether you have something like a building 6 by 8 meters and maybe 5, 6 meters high, and a few conveyors going in and out. But the most important thing, which must never be forgotten, the material has to be screened. So there has to be put a screen somewhere, even maybe outside, maybe inside, or maybe that screened material is already available. What amount of compressed air would be required for 5 to 8 tons per hour, which a material size 4 to 12 millimeter in terms of cubic meter per hour? Oh, I have to calculate this. That would I need a few minutes to do this, but 4 to 12. I think you're going to be okay with something like a 45 kilowatt compressor, but that is a gut feeling only. Otherwise, I have to sit down and do some calculation. And certainly, it all depends on the amount of ejected material. You know, the more you shoot, the more air you need. And if you don't know how many percent you have to be ejected, you don't know what it needs. But on average, I think 45 kilowatt is a good size for such an application. Maybe even less. Which warranty time or tons or hours is for your machine? Its typical warranty time is 1 year or maximum 6,000 operating hours, but it can be extended depending on different service level agreements which can be entered mutually. So it can be extended depending also on, let's say, spare parts availability and service contracts, whatever is there. Could you please give information about NIR process? Yeah, the NIR process is different. It scans the the wavelength of the near infrared spectra, and this can differentiate material of the same color. The challenge is here also the resolution of the NIR versus the color sorter or versus the laser sorter. The NIR resolution typically is a little bit less good than, it's much less high than for the color sorter, and it's a little bit less high resolution than a laser sorter. This is certainly the downside of it. In most cases, NIR is used on, let's say, separating talc, quartz, and carbonates from each other, for instance. This is where it is proven its its use. So for the quartz business, typically the NIR sorter is we try it, and sometimes it might be better, but in most cases we went to that color sorter only or laser sorter. Andreas Messinis from Greece, thank you, nice presentation. Are you further processing the data collected by the sorter? I mean, to implement kind of machine learning. Yes and no. An automatic machine learning is not foreseen because the machine needs the data to be processed extremely quickly, and if we collect too much data, we have to reduce the capacity, and that's what we do not want. On the other hand, certainly you could put in a second processor and divert the data and collect it and see how was the in-feed, how much was shot, and etc. And with this data, you can develop a statistics of what you have done and what you can expect for the future, or you can see the variation in your mine or whatever. Where are we down here? The next one. I hope this is enough. thanks for such a valuable presentation. It is very fruitful. I have seen the laser and color sorting application on Microman in Turkey, and it was quite successful. Do you have any application on chromite beneficiation? What do you think on combination of laser and color sorting with gravity separation on chromite or hematite? For chromite, I would go for X-ray. That's what I say, because we have quite some experience with the X-ray sorter on chromite. Problem is with all these ores, if they are not perfectly clean, then you don't see the surface, and especially if you have ores, hematite ore is a nightmare. Everything is rusty red, and you cannot do color sorting without having extremely good washing. So there are systems available which do not look at the surface, like the color sorter or the near infrared sorter. So some systems which look into the rock a little bit, and this is, for example, either electromagnetic for all the slags, or X-ray to have a differentiation of high grade and low grade ore. But I would love to talk about this with you personally, so we can look at all the individual applications and see where are the pros and the cons. But I think it's a little bit off topic if we concentrate on color and quartz here. But we will get in contact definitely. Do you have any sorter and dry process for above 100 millimeter? Yes. But as Jordan said, or let's say Jordan's professor said, it's necessary to liberate before you separate. If the material is liberated sufficiently at the sizes of plus 100 millimeter, it is no problem. So there are sorters. The secondary type is something between 20 to 100, 120 millimeters. And when we go to the very large sorter, which we call the primary, according to primary crushing, it's typically suitable from rocks from 50 millimeters to 250, 300 millimeters. So that's really possible. And then you also can achieve capacities for one sorter which easily exceed 200 tons an hour. Would you use a different technology for scavenging? Yes and no, depends on the individual case. Typically in a normal color application for engineering stone, no, because the quality factor is the color, or there are the colored impurities, and then I would use the same technology again for scavenging or cleaning. If I want to have another product line, for instance, then I could think about using another technology. But then you look for other quality parameters, like having separating quartz and non-quartz in the first step, and then separating the quartz by color in the second step. Then having the lowest grade of the quartz go into metallurgical processes, and the highest, whitest go into engineered stones. What is this? Do you have any product which has two-stage color sorting, one for sorting, another for scavenging the same, and what could probably cost? We do not use this type of machine having a two-in-one. It's the same as if you have two machines, and if you focus on one machine having both, and this one is down, then it's down. Now, if you have two machines, you can still run other material across it. We're focusing on quality, and it's better to have two machines running, even if they're positioned in line, than having everything squeezed into one. And it's not cheaper then. The probable cost for this two-step machine we do not have. It's all about the, let's say, how much does it bring you? And I have seen I've seen some machines coming from Eastern Asia which are not really performing as expected. So the price of such a machine typically is something out to 250,000 euros. Well, at least you will get what we promise. We keep our promises, and it's no reason to retrofit plants later because of non-performance. How many different sorter types do you have? We have two platforms, which is a chute platform for gravity and a belt platform, and we have 4 sensors which we can use, and we have single side or double side. We have different sizes, so overall the complete portfolio is roughly 20 different sorter types which can be used. Some are specialized on coal, some are specialized for diamonds, for instance. So there are lots of variations and specialties available here, which are really handmade, which are tailored to fulfill your needs as our clients. What's the next one here? And an extremely useful presentation. Then thank you, everybody. It was extremely useful presentation and discussion. Thank you for your time and input. Thank you, David. What do we have? Which process, laser or vision, is best when we have a lot of clear crystal quartz? To be separated from what? I think typically color sorter is the better option here if you want to separate the colored contaminants. I don't know if the other quartz is also, but here we can choose also different lasers. We have different colors in the laser, so we have to test this. I cannot say this just from a from the desk here. We really have to get into it. Have you ever considered if it's possible to apply laser or color techniques you use for gold? Yes, we have done this and it works, because the gold recovery on alluvial deposits, or let's say all these quartz associated gold deposits, the laser is quite helpful to pre-concentrate the material. We also have similar systems running on the pebble crusher circuit of mills. What is the percentage of runtime of the machines? Yeah, depending on how much spares you have at site, probably we are easily able to achieve plus 90% availability here. So pretty reliable. We are also planning to exploit a manganese ore deposit. Is there any application for sorters here? Yes, there is, and there you have to also look at what do you really want to separate. Manganese ore has the downside that the surface is extremely dark, and even the washing water is extremely black after one run. So we have, for example, seen that the near infrared sensor is giving us quite some advantage over other technologies. But also here, as said before, we are willing to do tests. We have the possibility to run different types of tests. Typically, we start with something what we call a first inspection. We just receive a handful of rocks, good rocks, bad rocks, some middlings. We expose this to the sensor and we just say, yes, it works, or no, it doesn't work. So basically, you get either a thumb up or a thumb down. And once we have decided it works, then we will go for a larger test session with a few tons and find out how good does it work, what will be the recoveries, what will be the grades, the achievable grades, etc., etc. Seems that's it. These are the questions I had. So quite a high number of questions. Thank you very much for this, for your active contribution. And for each of the askers or people asking the questions, we're happy to get into direct contact with you on a personal basis and discuss each and every case face-to-face on a telephone or video conference at the moment, but on a personal base later after this virus crisis has settled a little bit. And thank you very much.
Thank you, Jens, and thank you to our attendees for the valuable questions. So, well, this is the end of the webinar. We want to say thank you for your interactive participation. For us, it's important to have your feedback. That's why we will appreciate it if you fill out a short survey available after the webinar. I wish you a safe and happy day, afternoon, and night.